Hey guys, welcome back sa ating channel. Our topic for today is under structural steel design, which is the allowable compressive stress under NSCP 2010. So sa allowable compressive stress, so meron tayong dalawang case, which is the short column and long column. So masasabi natin na short column yung ating member when the KL over R is less than or equal to CC. Ano ba yung KL over R? Diba? Si L over R is the slenderness ratio. So may K na tayo or fixity factor, K, L over R is the effective slenderness ratio. And CC is the compression index. So, yun yung case 1. So, pag short column po, may formula tayo ng allowable compressive stress or allowable axial stress. So, 1 minus effective slenderness ratio squared over 2 CC squared times Fy over Fs. So, ano naman yung Fs? That is the factor of safety. So, may formula tayo ng factor of safety, which is 5 over 3 plus 3 over 8 times 1 KL over R or slenderness ratio over compression index minus 1 over 8 slenderness ratio over compression index cube. So, pag nasolve natin yung Fs, ilagay natin sa formula, masolve natin yung ating allowable compressive stress. Then, ito yung formula ng compression index, yung CC, square root ng 2 pi squared times E, which is yung modulus of elasticity ng ating steel, that times F over Fy. Then, case number 2, so when KL over R is greater than CC, or effective slenderness ratio is greater than CC, so siya ay long column. So, ito po ang formula natin sa long column. Allowable compressive stress is 12 pi squared E over 23, effective slenderness ratio squared, or kung familiar sa inyo to, this is the Euler's formula. So, yan. So, where yung L is the unsupported length or unbraced length. Then, yung KL over R is the effective slenderness ratio. Saan natin kukunin yung value ng K? So, depende sa support ng ating column. And fixity factor or K. So, when both ends are fixed, so gamitin natin K is 0.50. One end fixed, the other is hinge or pin support. Sa kabila, 0.70. Both ends are hinge or both ends are pin supported, so 1.0. And last, when one end is fixed, the other end is free, so 2.0. So, yun yung mga cases. Okay, ito yung mga factor na ginagamit. Okay. So, ito po yung kapag yung ating isang end is naka-fixed, then yung kabila is fixed, then fix, 0.5. Then, kapag fix and pin or fix hinge, 0.70. And fix, both ends are pin connected or hinge, is 1.0. And one end fixed and other end is free. So, 2.0 po yung ating end fixity factor. Okay, wala tayong problema dyan. So, alam natin yung formula. Short column, long column, then factor of safety, and the CC. So, try tayo ng isang example. So, a built-up section consisting of W350 by 90 with 12 mm plates to form a box section as shown. The section is used as column 10 meter long. The column is fixed at both ends and braced at mid-height about weak axis. Use Fy is equal to 48 megapascal. So, ibig sabihin 836 yung ating steel na ginamit. Kasi 248 yung ating Fy. Excuse me. Okay, paano yan? So, ito yung properties. Binigay yung properties ng 350 by 90. So, ang width ng flange is 250 mm. Total depth is 350 mm. Thickness ng flange is 16.4 mm. Thickness ng web is 9.5 mm. Given na rin yung kanyang moment of inertia along X and moment of inertia along Y. So, that's the total area ng ating W350 by 90. So, then meron tayong magkabilaan na 12 mm na plates. So, para makabuo tayo ng box section. So, number 1, compute the effective slenderness ratio of the column with respect to lateral backlink about x-axis or yung ating about strong axis. So, nasa previous video, pinaliwanag ko na ang pinagkaiba ng effect ng weak at saka strong axis. Number 2, compute the effective slenderness ratio of the column with respect to lateral buckling about y-axis or ating weak axis. And last, compute the axial load capacity of the column in kilonewton using NSCP. So, yan. Dito sa number 1, so alam natin formula dyan is KL over R. So, number 2, ganito yung KL over R kasi baga ibang axis lang yung hihingi. So, sa number 1, KL over R. So, since x-axis, so Rx. Sa number 2 is KL over Ry. So, alam natin yung formula ng radius of variation. R is equals to square root ng moment of inertia, depende sa kung anong axis, over total area. So, yan po yung formula ng ating radius of variation. Na-remind ko lang kayo, baka animutan. Ay, solution. So, ganito yung ating magiging, yung column natin is fixed. Fixed sa taas, and fixed about 10 meter long. Then, ganito yung ating section. So, meron tayong wide flange, 250 by 350, and meron tayong 12 mm plate, kabilaan. So, parang nakabuo tayo ng box section. So, kung mapansin nyo, sa beam is under, ba? Subjected siya sa bending. So, since ang ating column is, hindi ko na sinasabi na sa axial load lang siya, subjected. So, may bending din sa ating column. Ang pinupunto ko dito is, since i-design si column sa compression, so nilagyan natin siya ng dalawang plate, so para lalo siya lumakas sa compressive force. Tama? So, ang una natin gagawin is compute natin yung ating moment of inertia along X and along Y axis. Gamit yung transfer formula. Kung natatandaan nyo sa previous video natin, so, moment of inertia at neutral axis equals to Ix or Iy plus AD squared. So, yun yung general formula for the moment of inertia. So, shortcut yan. So, sub natin. So, Ix is equals to BD cube over 12 plus AD squared sa rectangular yan. So, given na yung Ix ng ating wide flange, so plus lang natin, is 266 times 10 raised to 6. Diba? So, transfer na yan. Plus, so sa steel is BD cube over 12. Ang base natin is 12. Ang depth is 350. So, magiging BD cube over 12 times 350 cube over 12 plus yung area niya is 12 times 350, which is yung D is distance dito sa x-axis. Since nandun na mismo yung sentro niya, so 0 na siya. So, sabihin dito is cancelled out. So, times 2 kasi kabilaan 1 and 2. Nandiyan, kaya meron tayong times 2. So, calculating. So, ang Ix natin, moment of inertia along x-axis, ito yung bagong moment of inertia ng buong section, ng box section na yan. So, 351.75 times 10 raised to 6. Then, Iy, itatransfer natin. Since kanina, natransfer tayo dito sa x-axis. Ngayon, tatransfer tayo papunta dun sa y-axis. Di ba ito yung y-axis? So, yan. Ganun din yung formula. So, magiging dB cube na sa rectangular. So, ito yung moment of inertia along y. Is 44.54 times 10 raised to 6. Doon na siya nag-act sa centroid na mismo along y. Plus, dB cube 350 times 12 cube over 12 plus the area, 12 times 350 times 131 times 2. So, yung 2, since magkabilaan, kaya times 2. So, saan nanggaling yung 131? So, dito po, galing dito is 250 divided by 2 is 125. Tama? 125 po ito. Then, galing sa centroid, sa gitna po nito, hanggang dito, since 12 yan, kalahati ng 12 is 6. So, 125 plus 6 is 131. That is the distance of the centroid ng rectangle to the y-axis. So, 125 plus 6 is 131. So, yan po yan. So, calculating, makuha natin value ng Iy is 188.7932 times 10 raised to 6 mm raised to 4. Ito yung moment of inertia along y. So, ito na yung moment of inertia ng buong section, ng bagong section na to. Then, computing na rin natin yung area. Total cross-section area is, since ito yung area, given na area ng ating wide flange, plus yung area na ng ating dalawang sheet 5, ng sheet na 12 ang kapal times 50 times 2. So, dalawa yan. So, total cross-sectional area ng back section is equals to 19,950 mm squared. Okay, yan yung mga kailangan natin sa pag-compute ng slenderness ratio. So, since dun sa x-axis natin is fixed support siya, kabilaan, so gagamitin natin reduction factor or end fixity factor is 0.5. Yung unbraced length is 10 meters. Yung IX yun yung na-compute natin X at saka IY. So, KL over RX or effective slenderness ratio along X is equal to 0.5 times 10,000, i-convert into mm, times yung formula nga ng radius of variation is square root ng I over area. So, along X is 351.75 times 10 raised to 6 over 19,950. So, calculating. So, effective slenderness ratio along X is 37.66. Sa along Y-axis, since sinabi doon na naka-brace daw along Y sa mid-height. Gets diba? Naka-brace siya sa Y. So, yung arrow ko lang is hindi ko napakita. Dito dapat siya. Yan. Diyan dapat siya naka-brace. Yung kabilaan. Gets ba? So, since ano yan, 5 meters na lang yan ang length. Since naka-fix sa dulo and naka-hinge dun sa dulo or pin connected, so may factor tayo na 0.7. Tama?
Okay.
So, end fixity factor kapag hinge and fix. So, kabilaan naman yan. So, kapag nagkataon na dito yung ating lateral support, so, say 7 meters, kasi nagkataon na nasa gitna, nasa mid-height. So, kapag may ganitong cases na 3 meters at saka 7 meters, kukumputin nyo parehas yung magiging ng kanyang effective slenderness ratio, di pipili tayo ng mas malaking value. Since malaki naman yung value ng 7, di 7 yung ating kukumputin. So, dito sa ating problems, nasa gitna, so 5 meters yung ating gagamitin. 0.7 times 5,000 mm over square root ng I over A, so yung IY over area. So, calculating effective slenderness ratio is along Y is 35.98. Since pipili, sa effective slenderness ratio, pipili tayo ng mas malaking value. So, ito yung gagamitin natin. Yan yung compare natin dun sa compression index na CC. Then, computin natin yung CC. Formula niya is square root ng 2 pi square times E over Fy. So, madali na yan. Direct substitution na lang yan. 2 pi square times 200,000 over 248. So, ang ating compression index is 126.17. So, then, compare nyo sa dun sa effective slenderness ratio ng 37.66. So, 37.66 is less than siya dun sa ating CC. So, kapag ganyan ang case, yan ay short column. So, pag short column, may formula tayo dyan na allowable compressive stress na 1 minus KL over R squared over 2cc squared times Fy over Fs. Since kailangan natin ng Fs, solve muna natin yung value ng Fs with the formula ng 5 over 3 plus 3 over 8 KL over CC minus 1 over 8 KL over R over CC cube. So, direct substitution na lang yan. May value na tayo ng KL over R, 37.66, and meron tayong value na CC. And then calculate lang. Solve natin yung Fs na 1.775. Since wala naman tayong conditions dyan, pag kung ano yung na-compute yung Fs, yun yung ating gagamitin. Since compared dun sa allowable bending stress na maraming conditions. Dito, okay na. Kung na-compute yung Fs, direct substitution na sa formula, masolve natin yung ating allowable compressive stress. So, direct substitution na sa formula 1 natin, 1 minus 37.66 squared over 2 cc squared, 248 over 1.775 na factor of safety. So, na-compute natin na FA is 133.49. Kasi sa number 3, pinapakompute yung capacity. Actual capacity ng ating column. So, balik tayo sa general formula ng stress. So, dapat 3 as, diba? Stress equals to force times area. Tama ba? Balik. Force over area. Yan. Ng stress is equals to force over area. Since meron tayong stress dito, which is yung allowable, ang pinapakuha sa atin is ng capacity P. So, kailangan natin i-multiply yung allowable, which is yung FA, allowable bending stress, to sa cross-section area. Paano makumpute natin yung capacity ng ating column? Intindihan ba? So, general formula is stress equals to force over area. P capacity is equals to allowable times area. So, 123.49 times total area 19,950. So, makakuha natin is 2,663,126 Newton. Or divide 1,000, makakompute natin is 2,663 kilonewton. Yun yung capacity ng ating column sa axial load. Okay?
Okay.
Then, problem 2. So, compression member. So, balik tayo sa number 1 muna. Ibig sabihin, sa number 1, doon sa ating problem, sa anong nag-guess nyo? Unang-una natin kinumpute is, sunod-sunod na yun, di ba? Pag-compute natin ng I, mag-compute natin is yung KL over R. Tama ba? Yung ating slenderness ratio. Pag compute natin yung slenderness ratio, check natin sa CC. Kung short column, solve for factor of safety. Kung long column, direction na tayo sa FA. Pag na-compute natin yung allowable compressive stress, ma-compute natin yung capacity. Allowable compressive force. Okay, so then I, then slenderness ratio, CC, then FS, then allowable compressive stress, and the capacity. Okay, bago na try yung problem number 2. So number 2, a compression member of a steel truss 4.5 meter long consists of two angles 150 by 100 by 10 mm with long legs back-to-back spaced at 10 mm apart. So, naintindihan nyo? So, natin papaliwanag. So, ibigay mo natin yung mga details. So, ito yung properties ng ating one angle bar. Ito yung angle bar, diba natin? 150 by 100 by 10. So, ang kanyang moment of inertia along X, binigay na. So, 5.58 times 10 to 6. Yung X, pakita natin sa drawing. Yan yung centroid niya. Since kanina kasi symmetrical yung ating figure, yung ating section. Dito, hindi siya symmetrical. So, yung ating cross-sectional area is 2,400 mm squared. Then, modulus of elasticity, alam nyo na yan. Then, IY, binigay niya na, moment of inertia along Y is 2.2 times 10 to 6. Then, yung kanyang Y distance from the centroid is 48.75. Then, FY niya is 345. Ibig sabihin, 8 to 6 yung ginamit. Okay? So, assuming that the ends are hinged and using NSCP specifications, determine the following. So, hinge daw yung both support. So, bakit hinge? Diba, si truss member yung binigay, diba, truss member yung binigay sa atin? So, compression, under siya compression. So, sa truss natin, so, hindi sinabi kung anong member to, kung web member ba, o top chord, bottom chord. So, familiar naman tayo sa pag-analyze ng truss. So, pag simply supported yung ating truss, automatic yung under compression is the top chord. Tama ba? Kasi yung bottom chord is under tension siya.
Galing yan.
So, assume natin na ito ay top chord na may haba na 4.5 meter long. So, back-to-back yung ating angle bar. So, ano ba ang pag-analyze ng isang truss, di ba? Yung lahat ng member natin, ang assumption is lahat yan is pin connected. So, ibig sabihin, yun nga, kahit hindi sabihin ito sa problem, alam natin na pin connected yung lahat ng truss member. Okay?
Galing yan.
Compute daw. Allowable axial stress, yung FA. Safe axial load, or yung capacity ng ating truss member, yung top chord nga. Then number 3, long leg back-to-back spacing to be equally strong at both axis. So, di ba ang strong axis natin is mas malaki yung I, X, I, Y. So, X axis yung ating strong axis. Weak axis yung Y. So, ano daw magiging spacing ng back-to-back angle, yung dalawang angle bar, ano daw magiging spacing para yung dalawang axis is pareho silang strong axis.
Ha?
Tumama tayo sa number 1. Ito yung drawing. So, exaggerated na yung drawing ko, masyado makapal. So, yun yung dalawang angle bar. So, yung sinabi sa problem, yung magkadikit is yung long legs. Longer legs, ito yung short legs niya. So, ibig sabihin ito is 150 by 100 by yung kapal niya is 10 mm. Lagyan natin yung kanyang axis. Ito yung kanyang X and saka Y axis. Yun yung centroid ng bawat angle bar. Y axis and X axis. Then, binigay na yung mga distance. Y bar. Yung Y distance is 48.75, given yan. Then yung X is 23.75. Then yung spacing, ang agwat ng dalawang face ng dalawang back is 10 mm. So, ang una natin gagawin, since yan naka-hinge support siya, so alam natin yung K. K,
Okay.
value ng K. So, i-compute natin yung transfer formula para makompute natin yung bagong Ix and bagong Iy. So, kasi binigyan na Ix is, given na Ix is moment of inertia siya ng isang angle bar lang. So, compute natin yung bagong Ix. So, since nasa X na to, gamitin natin yung transfer formula, mawala rin to kasi 0 na to. Tama ba? So, times 2 lang. Dalawang angle bar times 2 is magiging moment of inertia along X ng bagong section is 11.60 times 10 raised to 6. This Iy, gamitin natin yung formula. Sisend dito yung ating y, di ba? Ita-transfer natin siya dito sa y-axis. Kanina transfer din tayo kasi walang distance, kaya 0 na. Ngayon mayroon tayong distance, which is yung 53.75 times yung kalahati ng 10 na 5 meters lang to, di ba? So, yan. 2.20 times 10 raised to 6, yun yung Iy ng isang angle bar. Plus AD squared, yung area niya is 24 times 23.75 plus 5. Ito na yan, itong red line na to. Yung distance, yung d. Times 2 kasi kabilaan. So, moment of inertia along y-axis ng bagong section is 8,367.5 times 10 cube millimeter raised to 4. Compute na rin natin yung bagong area. Total area is 2,400. So, magiging 4,800 millimeters squared. So, yun na. Compute natin yung moment of inertia along x and moment, hindi, ang ano pala, slenderness ratio along x and slenderness ratio along y. Since x-axis is KL, ito na compute natin kanina, KL over Rx. So, ano magiging value ng K natin? Since both ends are ng hinge support or pin connected, so 1.0 yung ating gagamitin. So, ang unbraced length or unsupported length is 4,500. Moment of, ng radius of gyration is square root ng I over A. Ito yung Ix. So, natin is 93.33. Then, yung effective slenderness ratio along Y is KL over Ry. So, 1.0 times 4,500. Okay?
Okay.
Bakit 4,500 pa rin? So, wala namang lateral support along Y. So, sa number 1, is problem 1 natin is meron tayong lateral support sa bit height along Y-axis. Okay? Dito wala. So, compute effective slenderness ratio along Y is 107.70. Pagka-compute ng KL over R, ang kasunod na niyan is yung ng compression index or yung CC para malaman natin kung short column ba or long column. CC, formula, hindi nagbago yan, square root ng 2 pi squared E over Fy. So, kung 836 steel, so alam niyo na yung sagot kasi 248 ito. So, ngayon, 345 yung ating Fy. So, magiging CC natin is 106.87. Then, compare yung KL over Ry. Bakit KL over Ry yung ginamit natin? Kasi, mas malaki yung 107 sa 93. So, mas malaki kung gagamitin yung effective slenderness ratio. Yun yung i-compare nyo dun sa CC. Since yung ating effective slenderness ratio is greater than CC, so, ibig sabihin ito ay long column. Sa long column, wala tayong factor of safety, yung formula. So, diretso na tayo sa allowable compressive stress. May formula 2 pi squared over times E over 23 effective slenderness ratio squared. This is the Euler formula. Direct substitution. So, FA natin is allowable compressive stress is 88.66 megapascal. Okay?
Okay.
So, number 2, pinapakompute sa atin is the capacity. Yun nga kanina, stress is equal to force over area. So, para makompute yung force is stress times area. 88.66 times 4,800 na total air cross-sectional area, makompute natin is 425,568 Newton or 425.57 kilonewton. Okay?
Okay.
Yun yung magiging sagot natin. And last question, spacing daw para yung ating strong, yung pares yung x and y axis is strong axis. Siyempre, mag-base tayo dun sa strong axis na value ng Ix. So, ano daw yung magiging value ng ating spacing? Ito po. Okay? Okay, malito ha. So, moment of inertia along neutral axis, moment of inertia at neutral axis at x is equals to moment of inertia at y. So, meron tayong moment of inertia along x na 11.66 times 10 raised to 6. So, yun yung ating strong axis. Moment of inertia at strong axis. So, para mag-equate natin dyan para makampit natin yung S. So, 2.20 times 10 raised to 6 yung IY times 2 kasi dalawang angle bar plus ED squared yung area times D. Yung magiging D po natin is ito hanggang mula dito hanggang dito. Ano ba yun? 23.75. Ito ay magiging S over 2. Tama ba?
Ha?
So, yan. 2 4 plus 23.75 plus S over 2 squared times 2 kasi dalawa yan. Calculating, makumpute natin na spacing is 27.56 mm. Okay? So, ganun lang ang allowable compressive stress.
Galing yan.
Ang galing.
So, may mga problem ba na hinihingi yung allowable compressive stress ng mga ibang member? Meron naman. Kasi dito sa example natin, ang example ko lang is yung ating column at saka truss member which is yung bottom top chord ng ating truss. So, marami pang example. So, sana may natutunan kayo sa video natin ngayon. Allowable compressive stress under NSCP conditions. So, thank you. Sana natapos niyo yung video. Bye.
Please sa barakaray, whatever.